This is section 4.4. We're talking about trig functions at any angle, not just necessarily one that is on the unit circle. We're going to talk about trig functions, and we're going to talk about reference angles. Okay, the math behind this, most of the math that you have to do, the hardest thing is going to be like the Pythagorean theorem. But you're going to have to think a lot. All right, when I talk about the definition of a trig function at any angle, you are going to be given a point. They're going to say, here's a point on a terminal side. You can figure out all 6 trig functions. What you have to understand is when I give you a point, I'm giving you the x coordinate and the y coordinate, correct?
Yes.
Okay, so if I look here and I give you an xy that lies in the first quadrant, okay, you're always going to draw a triangle where theta is right here in the corner at the origin, always at the origin. So you're going to go directly up or down to the x-axis and left and right to the y-axis. But if your point, the terminal point that I give you, is in the first quadrant, what do you notice about the signs of x and y? If it's in the first quadrant, what are the signs of x and y? Positive. They're both positive. If it's in the second quadrant, what are the signs of your x and y? Negative and positive. Okay, this is important to know. If I give you a point that lies in the third quadrant, they're both what? Okay, it's negative, negative. And if I give you a point that lies in the fourth quadrant, it's what? Positive, negative. Signs are extremely important here. So like we learned before, when I gave you an x and a y and you told me, okay, well, the x was cosine, the y is a sine, 1 over is our reciprocal. It's a little different when the angle does not lie on the unit circle. There's not just one ordered pair that's always going to be every time. What you have to know are these trig functions. Same exact thing, guys. Sine is going to be y over your r, and I'll talk about r in a second. Cosine is going to be x over r. Your tangent is going to be the same, the y point over the x. So if I talk about the cosecant, it's the reciprocal of sine. So instead of y over r, it's going to be what? R over y. The reciprocal to cosine is our secant. Instead of x over r, it's going to be what? R over x. And our cotangent, you guys already know. If tangent's y over x, cotangent is x over y. Now, how to find the r? It's just the Pythagorean theorem. It's always going to be your hypotenuse. So, for instance, I give you a point that lies on the terminal side, and it's in the first quadrant, okay? Just draw. Doesn't matter where you put it. Just put it in the first quadrant. And I tell you that point is 3, 7. Okay? You have to draw the right triangle. I told you to draw the right triangle. You go directly down to the x-axis, correct? Then over to the origin. Everybody see that? Your theta should always be at the origin right here. That's the angle that we're referencing. What is 3 and what is 7 on this triangle? Okay, x and y. So tell me, where am I putting 3? On the x-axis. Where am I putting 7? What is my r? The hypotenuse. Every single time you guys are solving for r, you're finding the hypotenuse. Regardless of the signs, God bless you, regardless of the signs of x and y. Could be negative, could be positive. Not that it's a negative distance. It's just where the point lies. Your r is always going to be what kind of a number? Positive. Your hypotenuse is always going to be positive. Always. Because when you square a negative number, what happens to it? It's positive. So let's look at the next example. Okay, I've talked to you about this before, so I'm not going to spend much time on it. If I have a positive degree or radian measure, which way do we go? Up. If I have a negative degree or radian measure, which way do we go? Down. Okay, easy enough. When we talk about quadrantal angles, those are the ones that just lie right on the quadrant. All right, if I talk about 0 and 360 are the same. What is the ordered pair at 0? What's the x and what's the y when I go over to 0 or 2 pi? I go right or left? I go right 1 And up or down, nothing, correct? Yeah. If I'm at pi over 2, what did I do? I didn't go left or right any, correct? I just went up where? 1. Okay. What's the ordered pair for 180? I went negative 1, 0, good. And then what about 270?
0.
Good, 0, negative 1. So if you have anything where they ask for the quadrantal angle, you guys should know this, but you can figure it out. What is the sine of the quadrantal angle? What's the x? What's the y? 0. So my sine is 0. What's the cosine? 1. My tangent is what over what? Y over x, x over y. Y over x. So 0 over 1, which gives me 0, correct? All right, for 90, what's the sine? 1. What is the cosine? 0. Y over x. So 1 over 0 gives me what? Undefined. Good. For 180, what is my sine? What's the y? 0. What's the cosine? Negative 1. To find the tangent, it's 0 over negative 1, which gives me 0. Good. And then for 270, what's my sine? Negative 1. What's the cosine? And then what happens when I talk about tangent? Which is? Okay. You guys see that? You should know that. If that comes up or if that pops up, you guys should just be able to, you should know that. All right, so let's go back to some examples, what we were just talking about. If I ask you to determine the 6 trig functions given this information, right? This is easy. We're going to finish our triangle. Tell me where the 4 goes and where the 3 goes. 3 goes on the vertical. 4 goes where? So I have to find what? I got to find the hypotenuse. How do I find the hypotenuse? Pythagorean theorem. So 3 squared plus 4 squared equals r squared. 9 plus 16 equals r squared. 25 equals r squared. So r equals what? 5. So literally, guys, you know that your x is what value? 4. Your y is 3. And your r is 5. Now you can find all 6 trig functions. Okay, so what is the sine of theta? What is it? What over what? Y over r. So my sine is what? 3 over 5. Good. If my sine is 3 over 5, what is my cosecant? It's r over y, which is 5 over 3. Right? Yes or no? You guys okay? All right, so cosine of theta is x over r, correct? So it's what over what? 4 over 5. Good. So then my secant of theta is r over x, which is 5 over 4. Good. So tangent of theta and cotangent of theta. What is tangent? Y over x, which is 3 over 4. Yep. And then my cotangent is x over y, so it's 4 over 3. You guys okay with that? All right, so same thing here. We're going to draw our triangle. We're going to go down to the x-axis, over to the y. So tell me, where is negative 8 and where is 15? Okay, so x equals negative 8. Y equals what? 15. I have to find r. How do I do that? Pythagorean theorem. Guys, I know that that's negative. That's not a negative distance. That's where the point lies. So I would say negative 8 squared plus 15 squared equals r squared. What's negative 8 squared? 64 plus 225 equals r squared. What's 64 and 225? What is it? 289 equals r squared. So take the square root. So what does r equal? 17. Square root of 289 is 17. Good. Good job, guys. Wow. Okay. Okay, so we're going to do our trig functions. Sine of theta and the cosecant of theta. What is sine? Y over r. So it's what over what? 15 over 17. So my cosecant is 17 over 15. If I have my cosine of theta, I'm also going to find my secant of theta. So cosine is negative 8 over 17. So then my secant is perfect. And then I have my tangent and my cotangent. What is tangent? 15 over negative 8. Y over x, right? What's cotangent? Negative 8 over 15. Okay? Basic. If you have a radical and you have to simplify the radical, simplify. On WebAssign, they ask for exact. I got so many people sending me emails. So many emails. I put in 24.37 and it keeps saying it's wrong. Guys, exact means leave it in radical form. So make sure you're on top of that. All right. Yes. So on your test, this is how a question will be asked. Guys, pay attention.
Yes.
Point on a terminal side, blah, 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 blah. Find the 6 trig functions. The first thing I suggest that you do is draw a quick little picture. Where is the point negative 4, 7? What quadrant? Second quadrant. It's somewhere here. Okay, somewhere here. In order to draw my triangle, think about this because this makes a big difference. Think about this. I'm going to go down to the x-axis and then over to the y because I want my angle right here. So what my hypotenuse is always going to be like that. I want that angle from the origin. So where is negative 4? On the x. Where is my y? Okay, 7. So I know that x is negative 4, y is 7. I have to find what? R. How do I find that? Pythagorean theorem. So I have negative 4 squared plus 7 squared equals r squared. So 16 plus 49 equals r squared. What is 16 plus 49? 65. God bless you. Equals r squared. So what is r? How do I get r by itself? Take the square root. So r is the square root of 65. Can I break down square root 65? No. So you leave it, guys. You don't give me the decimal equivalent. You say that r is the square root of 65. So when you do your 6 trig functions, you're going to end up with a radical in the denominator. What do we do with that? You got to rationalize it. So you're going to find the 6 trig functions. I have sine of theta. I have my cosecant of theta. I'm going to have cosine of theta. And I'm going to have my secant of theta. I have tangent of theta. And I have my cotangent of theta. Correct? Remind me, what is sine? What over what? Tell me the letters. Y over r. So it's 7 over root 65. Can I leave that? I have to rationalize the top and bottom by what? Root 65. So this will be 7 root 65 over 65, right? Can I cancel out the 65s? No. No. So if my sine was 7 over root 65, what's the cosecant? Okay, so it's what? Root 65 over 7. Cosine, what over what? So it's negative 4 over root 65. It's x over r. Can I leave it like that? No, we have to rationalize top and bottom by root 65. So this ends up being negative 4 root 65 over 65, right? So if my cosine is x over r, my secant is r over x. Well, what's the r? Root 65 over what? Negative 4. Tangent is what over what? So it's y over x. So it happens to be negative what? y over x be negative 7 over 4. It doesn't matter where you put the negative. So my cotangent is x over y, which is what? Negative 4 over 7. We good? Let's move on to this one. Again, draw yourself a quick little picture. It makes things easier. If I draw a quick picture, where is this point? 3, negative 4. What quadrant? Fourth quadrant, somewhere here. So when I draw my triangle, I'm going to go to the x-axis, over to the origin, and then there's my hypotenuse. So 3 is here, yes? Negative 4 is here. What am I finding?
R.
My r. So I know that x equals 3, y equals negative 4. Figure out r. How do we find r? Pythagorean theorem. So I have 3 squared plus negative 4 squared equals r squared. 9 plus 16 equals r squared. 25 equals r squared. So what's r? You guys with me? Okay. So I have my sine of theta. I have my cosecant of theta. I have cosine theta, secant theta, tangent theta, cotangent theta. Okay? Remind me again. I know we said it 100 times. Let's say it 101. What is sine? What over what? Y over r. So what is it? Negative 4 over 5. So if sine is y over r, my cosecant is r over y, which is 5 over negative 4. All right, cosine, x over r, yes? What's my x? What's my r? 3 over 5. So my secant is r over x, 5 over 3. Cotangent, what over what? Y over x. So it's what? Negative 4 over 3. So cotangent is x over y, which is? Negative 3 over 4. Guys, remember, it is so important your signs. If you have 2 negatives on a problem, a negative divided by a negative is a positive. If you don't cancel things out like you should or something like that, if you miss a negative, the problem is wrong. I cannot give you partial credit. This is like an all or nothing kind of thing. So we need to make sure that we're on top of things. If you don't do the Pythagorean theorem right at the very beginning, what happens to every single one of these answers? It's wrong. So pay attention to what you're doing. Okay? All right. This is extremely, extremely, extremely important. Signs of trig functions. You're going to be given parameters. You're going to say, I need to find this angle where the sine is less than 0, but the tangent is greater than or equal to, whatever. You guys have to pay attention. You have to understand what this is saying. In quadrant 1, everybody understand this is quadrant 1. Yes? Every single trig function, sine, cosine, tangent, cosecant, secant, and cotangent, is always positive. Why is that? What are the x's and the y's in the first quadrant? Positive. So at any point, you have a point on a terminal side or any angle that's in the first quadrant, it's all trig functions are positive. In the second quadrant, all the trig functions are negative except for sine and cosecant. In the third quadrant, everything is negative except for tangent and cotangent. And in quadrant 4, everything is negative except for cosine and secant. So an acronym that you can remember is all students take calculus. Is that true? All students take calculus? No. Okay. The book also says all snakes tease chickens. I don't know. A smart trig class. When we talk about the quadrants, it's in a big C, right? Like this. Quadrant 1 starts here. So it's A, S, T, C. Here is why this is important. You'll have a question on your test, and this is what it says. There are no numbers involved here. They want to know what quadrant the angle lies in. Okay, which quadrant? 1, 2, 3, 4. If these two things happen, so the first thing, in order to show me your work and in order to figure this out, I would draw a coordinate plane. Everybody with me? And I would write A, S, T, C. Okay. When I say all, what does that A mean? All what? No, all what? Everything. All trig functions. All 6 trig functions are what sign? Positive. In the second quadrant, what is the only thing and its reciprocal that is positive? Sine and cosecant. In the third quadrant, what is the only thing positive? Tangent, cotangent. In the fourth quadrant, what is the only thing positive? Cosine and secant. So watch what this says. This says the cotangent of theta is greater than 0. What does that mean? That means that tangent is positive. So go back to your thing. Where, say the letters, where is tangent positive? A and T, right? So cross off S and C. So now I have it narrowed down to 2. Now the second parameter says that sine is less than 0. What does that mean? Sine is negative. So with what I have remaining, what can I cross off? The A, because I know that in that quadrant, everything is positive. So the second parameter is checked off there. So what quadrant does this random theta lie in? Quadrant what? 3. That's how you would answer that question. There is absolutely no number that you would say, oh, it's which quadrant. You have to know where the different trig functions are positive and negative. Okay? All right. So if I have, this is how you'll see types of questions on your test. Given that cotangent of theta is negative 4/3, and sine is greater than 0, find the following. Okay, first thing you need to do is draw a picture. All right, what do I know? Write down what you know. Cotangent is what? What over what? But it's what over what? Cotangent. X over y. So I know that the cotangent is negative 4/3. I don't know, guys, if there's a negative in front, it doesn't just automatically go with the number it's with. It could be with the 4 or it could be with the 3. You guys see that? Okay, so what they're giving me, I have X, Y, and R. You guys just told me that cotangent is X over Y, correct? So X I know is 4. Y I know is 3. I don't know which one is negative though. You guys with me? Okay, so the first thing I'm going to do is cross off what this cannot be. I got to think a little bit here. My cotangent is negative. So that means it cannot be in which 2 quadrants? Cannot be in T because that's where it's positive. And it cannot be where? In A. Okay. So the second thing it says, sine is greater than 0. That means the sine is what? Positive. Where is the sine positive? In the second quadrant. So what do you know about your X value and about your Y?
The X is positive.
If it's in the second quadrant, X is negative, right? Because you go left, then up. So X is negative, positive. Like that, right? Next. So I know it's negative 3, positive, negative 4, positive 3. You guys have to do that because if you put the negative with the wrong one, it happens right now that the negative's in front of the 4 and you're like, oh, I already knew that because I could see it. No. It's not always going to be that. When you put a negative out in front of a fraction, you don't know if it goes to the numerator or the denominator. So now that we have that sorted out, it's really easy to find all the trig functions. What do I have to find first? The R. So I have negative 4 squared plus 3 squared equals R squared. 16 plus 9 equals R squared. 25 equals R squared. So what is R? 5. Now can we find the trig functions that are left? Yeah, it's real easy. What is sine? What over what? Y over R. What's cosine? X over R. What is secant? R over X. What is cosecant? R over Y. So now just fill in, given the numbers that we have. Y over R, 3 over 5. Okay. X over R, negative 4 over 5. R over X, 5 over negative 4. R over Y, 5 over 3. So that is how you'll be asked on your test how to figure out these things. That problem takes a little bit of time. I'm not going to be able to give you 25 questions on this test. You have to know what you're doing. You have to be able to work in a timely manner, but there's not going to be a million questions. You guys see that? We okay? All right. These are the quadrant angles. If we just went over this at the beginning. What is the ordered pair for pi? Negative 1, 0. Good. So if you guys didn't remember the y over the r, the x over r, that sort of thing, think about this. X is negative 1, right? Y is 0. If I found r, I would use what? Pythagorean theorem. I'm showing you why this works. So I have negative 1 squared plus 0 squared equals r squared. Negative 1 squared is 1 equals r squared. The square root of 1 is 1, right? So r is 1. So if you were going to find the sine is what over what? Okay, so sine of pi is, what is it? Y over r. Okay, what's my y value? 0 over r. So it's what? 0. Could you just look at that and know that sine is the y value? Yes. Cotangent. Well, what is the ordered pair for 3 pi over 2? 3 pi over 2? 0, negative 1. Okay. Remind me again. So x is 0. Y is negative 1. If I use the Pythagorean theorem, what would r be? Positive 1. Cotangent is what over what? X over y. So x is 0. Y is negative 1. What would my cotangent of 3 pi over 2 be? 0. Okay, good. Guys, to find a reference angle. Okay, reference angle of theta is the acute angle formed by the terminal side and the horizontal axis. What I want you guys to take from this is I want you to write these two words down. Acute. What does acute mean? Smaller than 90. Acute and positive. We're going to talk about 4 different scenarios. I'm going to go through some problems with you and then we're done. Again, this is not going to be terribly difficult, but you're going to have to, yeah. Would you guys agree with me that this angle that I just drew is in quadrant 1?
Yes.
Yes? If the reference angle they give you is in quadrant 1, if the angle they give you is in quadrant 1, okay, they tell you that theta is whatever in quadrant 1, then your reference angle is that angle. Meaning, if I gave you an angle degree and I said angle is 28 degrees, what is the reference angle? You guys would tell me it's what? 28 degrees. If it's in the first quadrant, whatever angle they give you is equal to the reference angle, because your reference angle is an acute angle that is drawn between the x-axis, right here. That's your reference angle. That's how you would draw it. The x-axis and the origin. So, if I gave you an angle here, okay, what angle is that in? What quadrant? I'm sorry. This is in quadrant 2. So to draw my reference angle, I would go down here to the x-axis and over to the origin. You guys see that? If your angle is in quadrant 2, to find the reference angle, you would say 180 minus the angle given. That will give you your reference angle. Or if it's in radians, instead of 180, what would you use? Pi. What are the two things after you do your calculation that your reference angle will be? What are the two things that your reference angle will be? Positive and acute, if you did it correctly. So we'll talk about that in a second. All right, so now going over here. If I give you an angle and I say this angle, which is, I don't know, 285 degrees. All right, what quadrant is that angle in? It's in quadrant 3. You would draw your reference angle to the x-axis to the origin. So you're going back, right? So in this case, to find your reference angle, you would say the angle that they gave you minus 180 gives you your reference angle. Or you would say your reference angle minus pi gives you your reference angle. How are quadrant 3 and quadrant 2 different? Correct. Correct. In quadrant 2, the angle they give you is less than 180, so that's why it's 180 minus. In quadrant 3, the angle they give you is more than 180. That's why the angle goes first. But if you guys do the math and you do it wrong, say I told you this was a measurement of 290, and you said, okay, 180 minus 290, you're going to get what kind of a number when you say 180 minus 290? Negative. A reference angle has to be what? Positive. So you should see that. You should be like, oh, wait, I messed up. And then the last one that we're going to talk about, this one's easy too. If I give you an angle and it ends up being here, right? I go around like this. What quadrant is that angle in? 4. So in order to draw my reference, I would go from here, I'd go directly up to the x-axis and over to the origin. So I would say 360 minus the angle they gave me. That's going to give me my reference angle. Or what's the same thing as 360 in radians? 2 pi minus the angle equals a reference angle. Okay? You have to remember those things. The calculation is either 180 minus angle minus 180 or pi, or 360 2 pi minus the angle. That's it. The math behind this, the computation, not hard, but you're going to have to reference what angle we're in and that sort of thing. I mean, what quadrant? I'm sorry. All right, so let's do a, we're done. Okay, the way that we're going to do this, find the reference angle, blah, 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 blah. First thing you should do, I think, because 2 pi over 3, does anybody know what quadrant 2 pi over 3 lies? Are you sure? Okay. If you're not sure, if you guys are not for sure where it lies, I would convert, first of all, to degrees. Just makes it easier. You guys will have a calculator. It makes it easy to do this. So if I convert, my pi's cancel out, correct? 3 goes into 180 60 times. What's 2 times 60? 120. So draw yourself a quick little picture. 120 is in what quadrant? 120 is in what quadrant? Quadrant 2. So my reference angle is going to be right here. If your angle given lies in quadrant 2, what is the rule?
180 minus that.
Okay, 180 minus 120 gives me what? 60 degrees. Check your answer. Is it positive and acute? Yes. What did I start off with? Radians. So what should I end up in? So just convert it back. So my zeros cancel out. 6 goes into 6 once. 6 goes into 18 3. So my reference angle is pi over 3. You just have to know whether it's the reference angle equals the angle, whether it's 180 minus, angle minus 180, or 360 minus. I knew this was going to be long. All right, what about this one? 23 pi over 6. Where does that lie? You guys don't know? Okay. Let's convert it. Let's convert so we can see. Pi on the bottom, 180 on the top. So pi's cancel out. 6 goes into 180. How many times? 30. What's 23 times 30? Come on. Okay, so 690 degrees. Well, first of all, what do you notice about that number? It's big. It's bigger than what?
360.
Okay, so if I were to draw this, it's going to go around one whole time and then around. How much more does it go around? I don't know. How would I figure that out? Okay, let's minus 360. See if that gets me below 360. What's 690 minus 360? 330. What quadrant is 330 in? Quadrant 4, right? So look, my reference angle is going to be formed right here. What is the rule for quadrant 4? Quadrant 4 is 360 minus the reference angle. What is 360 minus 330? 30 what? Degrees, right? Okay, check. Is that number acute and positive? Yes. So are we okay? Last thing I need to do? Convert it back to? Yep. So 30 goes into how many times? So my answer is pi over 6. Pi over 6. We good? God bless. Okay, last thing. Take a picture. You guys have to know the special right triangles pattern. Yes, you will be asked a question or two on your test that says, given blah, blah, blah. I want the exact value. Exact means no decimals. We will practice this tomorrow on your web assignment. I will go over some problems on Wednesday, but you guys have to know the pattern. So say I told you that this side right here was 6 radical 2. What are the legs? Each leg is how much? 6. All right. If I told you, guys, if I said to you that this side was 10, what are the legs? No. You would have to set up a little equation. You would have to say that x radical 2 equals 10. How would I get x by itself? Divide both sides by radical 2, right? So x equals, can I leave 10 over radical 2? No, I'd have to rationalize. So this would be 10 radical 2 over 2, which would then be what? So both the legs would be 5 radical 2. You guys are going to have to be able to do that. You have to. We'll work on some problems tomorrow and Wednesday, but you have to be able to manipulate the special right triangles without using your calculators for decimals, okay? All right.